Hello, welcome to Cloud Learning channel. In this module, we will discuss all Snowflake related interview questions. We have about 40 questions in this module, and I will explain you each question, and I'll give you a detailed description about that particular Snowflake interview question. Let's start. Question 1. What is Snowflake? A Snowflake's data cloud is powered by an advanced data platform provided as SaaS service. The SaaS means a software as a service. A Snowflake enables data storage, processing, and analytics solutions that are faster, easier to use, and far more flexible than traditional offerings. The Snowflake data platform is not built on any existing database technology or big data software platform such as Hadoop. The Snowflake combines a completely new SQL query engine with an innovative architecture natively designed for the cloud. So, if I want to say in a user view, Snowflake provides all of the functionality of an enterprise analytic database, along with many additional special features and unique capabilities. And let's start. What is it? I mentioned Snowflake is a SaaS service. So Snowflake is a true SaaS offering, and there is no hardware to select, install, configure, or manage. And also there is virtually no software to install, configure, or manage. No ongoing maintenance, no management, no upgrades, and also tuning are handled by Snowflake. That's why we call Snowflake is a true SaaS offering. Snowflake runs completely on cloud infrastructure. So all components of Snowflake services are run in public cloud infrastructures. And Snowflake uses virtual compute instances for its compute needs and a storage service for persistent storage of data. So Snowflake cannot be run on private cloud infrastructure that is on-premise or hosted. Let's go to question 2. Explain the Snowflake architecture. And Snowflake's architecture is a hybrid of traditional shared disk and shared nothing database architecture. And similar to shared disk architecture, Snowflake uses a central data repository for persistent data that is accessible from all compute nodes in the platform. But similar to shared nothing architectures, Snowflake processes queries using a massively parallel processing compute clusters, that is MPP, where each node in the cluster stores a portion of the entire data set locally. So this approach offers the data management simplicity of a shared disk architecture, but with the performance and scale out benefits of a shared nothing architecture. And if you want to learn more about the Snowflake architecture, there is a module available in my channel, and please go through that architecture module. And that module explains you, like end-to-end Snowflake architecture, so you can understand it better. And let's go to next question. What are the 3 key layers in Snowflake's unique architecture? So we see the 3 unique key layers: database storage, query processing, cloud services. So Snowflake's unique architecture consists of 3 key layers. They are database storage, query processing, cloud services. Let's talk about each key layer in detail. Let's start with database storage. When data is loaded into Snowflake, Snowflake reorganizes that data into its internal optimized compressed columnar format. So Snowflake stores this optimized data in cloud storage. Snowflake manages all aspects of how this data is stored: the organization, file size, structure, compression, metadata, statistics, and other aspects of data storage are all handled by Snowflake. We already discussed in question 1 that Snowflake is a SaaS service. true SaaS service so that we don't have to worry about anything, the file size, structure, compression, metadata, statistics. So all handled by Snowflake. The data objects stored by Snowflake are not directly visible nor accessible by customers. So they are only accessible through SQL query operations run using Snowflake. So we can't see anything like, how Snowflake organizing all this, but we can retrieve the result just using SQL query, and we can use that SQL editor. And I'll tell you, like, how we can do the queries and access that data. And there are also a lot of modules available in the channels if you want to go and look at it. So, and we don't have to worry about it. And like Snowflake mentioned, the data objects stored by Snowflake are not directly visible nor accessible by customers. That let's talk about the next key layer. The next key layer is query processing. Query execution is performed in the processing layer. Snowflake processes queries using virtual warehouses. Again, if you want to run anything in Snowflake, so we must have virtual warehouse. So that is a compute. So we cannot run any query, we cannot create any table, anything without a warehouse. We can create like a database or something, but we must have virtual warehouse. Each virtual warehouse is an MPP, the massive parallel processing compute cluster composed of multiple compute nodes allocated by Snowflake from a cloud provider. So each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. As a result, each virtual warehouse has no impact on the performance of other virtual warehouses. Let's talk about last key layer, that is cloud services. The cloud services layer is a collection of services that coordinate activities across Snowflake. So these services tie together all of the different components of Snowflake in order to process user requests from login to query dispatch. The cloud services layer also runs on compute instances provisioned by Snowflake from the cloud provider. The services are managed in the cloud services layers, including authentication, infrastructure management, metadata management, query parsing and optimization, and access control. Let's go to next question. How do you connect to Snowflake? So Snowflake supports multiple ways of connecting to the Snowflake. So we can connect to Snowflake using web-based user interface, command line clients, ODBC and JDBC drivers, native connectors, and some third-party connectors. Let's talk about the first connection type here, a web-based user interface. A web-based user interface from which all aspects of managing and using Snowflake can be accessed. And the second one, command line clients. Command line clients which can also access all aspects of managing and using Snowflake. Example, SnowSQL. We can use that SnowSQL to connect to Snowflake. The next one, ODBC and JDBC drivers. ODBC and JDBC drivers that can be used by other applications to connect to Snowflake. Example, in a Tableau, we have the drivers, so we can use that to connect to Snowflake. If we have Teradata, if we have anything like, if we have Oracle, whatever we have, the ODBC, JDBC drivers, we can connect to Snowflake using that. And the next one is native connectors. Native connectors that can be used to develop applications for connecting to Snowflake. Example, Python Spark. And the last one, third-party connectors. Third-party connectors that can be used to connect applications such as ETL tools and BI tools to Snowflake. So if we talk about ETL tools like Abnisio, Informatica, or some other ETL tools, and if we talk about BI tools, there is Amazon QuickSight or any, there are a lot of BI tools, Power BI, or Tableau, or Denodo, so, and also ThoughtSpot. So all these BI tools also that can support to connect to Snowflake. The next question, what are the native SQL development and data querying interfaces given by Snowflake? Snowflake provides the following native SQL development and data querying interfaces. They are Snowsight worksheets, SnowSQL, Snowflake SQL extension for Visual Studio Code. Let's talk about the Snowsight worksheets. They are browser-based SQL development and editing. So no installation or configuration required for the Snowsight worksheets. And they support multiple independent working environments that can be opened or closed or named and also reused across multiple sessions. The next one is SnowSQL. A SnowSQL is a Python-based client for performing all tasks in Snowflake, including querying, executing DDL commands, and also DML command, and bulk loading and also unloading of data. And we can download that SnowSQL going into Snowflake documents, and there you see the SnowSQL download page. And the last one is Snowflake SQL extension for Visual Studio Code. And Snowflake provides an extension for Visual Studio Code to enable Snowflake users to write and execute Snowflake SQL statements directly in Visual Studio Code. And we can install the extension directly from within Visual Studio Code or indirectly by downloading a specific version. The next question, what is SnowSQL? We just talked about SnowSQL, but let's talk a little more detail about the SnowSQL. SnowSQL is the command line client for connecting to Snowflake to execute SQL queries and perform all DDL and DML operations. That includes loading data into Snowflake and also unloading data out of Snowflake database tables. And SnowSQL is an example of an application developed using the Snowflake connector for Python. However, the connector is not a prerequisite for installing SnowSQL. So all required software for installing SnowSQL is bundled in the installers. So if you want to install this SnowSQL, you can just go to Snowflake documents and there you see the download link. So you can download using that link and install it. Let's go to next question. Snowflake extension for Visual Studio Code. What is Snowflake extension for Visual Studio Code? A Snowflake provides an extension for Visual Studio Code to enable Snowflake users to write and execute Snowflake SQL statements directly in Visual Studio Code. The extensions are pre-packaged functionality often provided by third parties, which add new features and functionality to Visual Studio Code. If you have any questions on installing, or if you are running into any errors, if you are getting any issues with downloading, and please go to Snowflake Docs, and there you see all step-by-step installation process to install this connector. Let's go to the next question. What are an internal stages? There are three internal stages: user stage, table stage, and named stage. And Snowflake maintains these stage types in our account. Let's talk about user stage. A user stage is allocated to each user for storing the files. This stage type is designed to store files that are staged and managed by a single user but can be loaded into multiple tables. So user stages cannot be altered or dropped. The next one is table stage. What is table stage? A table stage is available for each table created in Snowflake. This stage type is designed to store files that are staged and managed by one or more users, but only loaded into a single table. And again, table stages are also cannot be altered or dropped. And let's talk about the last stage, named stage. Before I go to named stage, let's talk about there is one more note on this table stage. A table stage is not a separate database object. Rather, it is an implicit stage tied to the table itself. So table stage has no grant table privileges of its own. So to stage files to a table stage, list the files, query them on the stage, or drop them. So we must be the table owner. And let's talk about the last stage, name stage. What is name stage? A name internal stage is a database object created in a schema. This stage type can store files that are staged and managed by one or more users and loaded into one or more tables. Because named stages are database objects, the ability to create, modify, use, or drop them can be controlled using security access control privileges. Let's go to next question. Question 9. What is an external stage? Loading data from any of the cloud storage services that is supported by regardless of the cloud platform that hosts in our Snowflake account. So the external cloud storage services are Amazon S3 and Google Cloud Storage and Microsoft Azure. A name external stage is a database object created in a schema. This object stores URL to files in cloud storage. The settings used to access the cloud storage account and convenience settings such as the options that describe the format of staged file. So create stages using the command create stage. And we cannot access data held in archival cloud storage classes that requires restoration before it can be retrieved. So these archival storage classes include example Amazon S3 Glacier or Microsoft Azure Archive Storage. Let's go to next question. What is bulk versus continuous loading? Snowflake provides the main solutions for data loading. The best solution may depend upon the volume of the data to load and the frequency of loading. Let's talk about bulk loading. A bulk loading using the copy command. This option enables loading batches of data from files already available in cloud storage or copying data files from a local machine to an internal cloud storage. So internal cloud storage means here in Snowflake. And before loading the data into tables using the copy command. So here the internal cloud storage is Snowflake, and other cloud storage means that external cloud storage means either Amazon S3 or Microsoft Azure ADLS or Blob or Google Cloud Storage. And let's talk about the compute resources and simple transformations during a load in bulk loading using the copy command. So the compute resources, bulk loading relies on user-provided virtual warehouses, which are specified in the copy statement. Users are required to size the warehouse appropriately to accommodate expected loads. So if you want to know how to size this warehouse in Snowflake, just go to my other modules where you can find out, like, there are small, medium, large size. So we can always, if you already created one and you can resize it, and please refer those modules if you want to resize your warehouse when you're doing this bulk loading using the copy command. Let's talk about simple transformations during a load. Snowflake supports transforming data while loading it into a table using the copy command. So it includes the options column reordering, column omission, cache, truncating text strings that exceed the target column length. Let's talk about the continuous loading. So this continuous loading using Snowpipe option is designed to load small volumes of data and incrementally make them available for analysis. So Snowpipe loads data within minutes after files are added to the stage and submitted for ingestion. So it ensures users have the latest results as soon as the raw data is available. Let's talk about compute resources and simple transformation during a load in continuous loading using Snowpipe. I'm talking about compute resources. Snowpipe uses compute resources provided by Snowflake. These Snowflake provided resources are automatically resized and scaled up or down as required and are changed and optimized using per second billing. As I mentioned earlier, copy command, we can resize our warehouse as per our load size. But here Snowflake manages simple transformation during a load is like the copy statement in a pipe definition supports the same copy transformation options as when bulk loading data. Let's go to next question. How to query your data in cloud storage without loading it into Snowflake tables. External tables enable querying existing data stored in external cloud storage for analysis without first loading it into Snowflake database. The source of truth for the data remains in the external cloud storage. Data sets materialized in Snowflake via materialized views are read-only. So like I mentioned, what is external cloud storage? They are like external cloud storage are Amazon S3, Microsoft Azure Blob, Google Cloud Storage. And this solution is especially beneficial to accounts that have a large amount of data stored in external cloud storage and only want to query a portion of the data. So example, if we have a most recent data, and users can create materialized views on subsets of this data for improved query performance. This is how we can query our data in cloud storage without loading it into Snowflake table. So we don't have to bring that data into Snowflake, and we can just use this external enable option and then query the data from that external cloud storages. Go to next question. How do you handle loading large data sets in Snowflake? Loading large data sets can affect query performance. And how do we overcome this issue in Snowflake? So Snowflake recommend dedicating separate warehouses for loading and querying operations to optimize performance for each. So the number of data files that can be processed in parallel is determined by amount of compute resources in a warehouse. Again, so if you are getting a huge volume of data, and make sure that you resize your warehouse. If you create your warehouse with the small, then you can you can resize it to medium or large based on your volume. And if you follow the file sizing guidelines described in Snowflake doc, a data load requires minimal resources. So if you don't have a minimal resource, then you may face the issue while loading data into Snowflake. So you make sure you follow all the recommendations that file size guidelines described by Snowflake and Snowflake docs. And splitting larger data files allows the load to scale linearly unless we are bulk loading a large number of files concurrently, that is hundreds or thousands of files, and a small warehouse that is small, medium, large is generally sufficient. So using a larger warehouse that is extra large or double time extra large will consume more credits and may not result in any performance increase. So when you resize the warehouse, so you must remember that there is a cost associated with that size. So if you are going for small, then the cost is little less. And if you are keep increasing it, then you are paying your cost also varies. So but please keep that in mind. So when you're handling a large data sets in Snowflake. Let's go to next question. What are the options for selecting stage data files? The copy command supports several options for loading data files from a stage. So by path or prefix, the by path means internal stage and prefix Amazon S3 bucket, and also specify a list of specific files to load. And again, if you want to know how to load the data from Amazon S3 or Google Azure into Snowflake, and please go through my channel, and there I did a couple of good exercises, like how we can specify a file to load in our Snowflake table. And let's say in your external cloud storage, you have a lot of files existing in the bucket, and but you want only one file to load in a Snowflake database, you can specify just like that one file to load into Snowflake. And please go to that module, and you can find more details how to do that. And the last one is using pattern matching to identify specific files by pattern. So there you can star, and then you can mention the file name and then star dot. So then it detects the specific pattern to match that file and bring that file into Snowflake table. So please go to that module, how to load the data from external cloud storage into Snowflake. So it helps you to understand much better how to load the data. And all these options enable you to copy a fraction of staged data into Snowflake with a single command. So it allows you to execute concurrent copy statement that match a subset of files and taking advantage of parallel operation. Let's go to the next question. What are the supported file formats in Snowflake? And the supported file formats structure, I just listed here the structured and semi-structured. So what are the structured file formats supported? They are delimited, example CSV, TSV, and any valid single byte delimiter is supported, and default is comma separated. And the next one is semi-structured. What are the file formats? JSON, Avro, or Parquet, and XML. And Avro, it includes automatic detection and processing of compressed Avro file. And same applies to OR files, automatic detection and processing compressed. And also same applies to Parquet. And the XML supported as a preview feature, but if you want to get an update on that XML format type, please follow that Snowflake latest update so that you get whenever it is available in Snowflake. Right now it is in the preview feature. Let's go to next question, 15th question. How do you perform a bulk loading from a local file system? So if you want to load a file from a local system into Snowflake, but how do you perform it? It's very simple. Loading data from our local machine is just two steps how to load the data from a local file system. The first one is upload the files into a Snowflake stage using the put command, using a put command. And the second one is you can use a copy into command and just mention the table, whatever you have in a Snowflake, just mention the table, copy into the table command to load contents of staged files into a Snowflake database table. Regardless of stage that you use in this step, it requires a virtual warehouse that is also concurrent warehouse for the session. Again, as I mentioned earlier, the warehouse provides the compute resources to perform the actual insertion of rows into the table. You can create a database table, but you must have warehouse to load the data into Snowflake database table. 16th question. What are the steps involved in loading data from an AWS S3 bucket? It's just two steps that I mentioned, loading from local file into Snowflake and also loading AWS S3 into Snowflake. It's not a big difference. The first step involved in loading data from S3 bucket into Snowflake is Snowflake assumes the data files have already been staged in an Amazon S3 bucket. If they haven't been staged yet, we have to use the upload interfaces utilities provided by AWS to stage the file. And what is the final step? Step 2, we can use the same command, copy into a table. The table is whatever we have in a Snowflake. We can use this copy into table command to load the contents of the staged files into a Snowflake database table. We can load directly from the bucket, but Snowflake recommends creating an external stage that references the bucket and using the external stage instead. And regardless, whatever method we are using, we must have the warehouse. And also, if you are bringing huge volume, and make sure you resize the warehouse. And let's go to next question. And what are the steps involved in loading data from a Google Cloud Storage bucket? Like I mentioned, in AWS S3, we need to stage and bring the data into Snowflake, and we need to make sure, like, there is a warehouse available. And the same thing, loading data from a storage bucket is performed in two steps. The step one is Snowflake assumes the files already staged in a cloud storage bucket. Cloud storage bucket is cloud storage in Google Cloud. And if you want to learn about cloud storage, how it works in Google Cloud, and please go to my channel, and there is a good module available how this cloud storage work in Google Cloud. And let's come back to the step one again. If those files are not staged, and use the upload interfaces utilities provided by Google to stage the file. And the step two, and use the copy into table command to load the contents of the staged files into Snowflake database table. And we can load directly from bucket, but Snowflake recommends creating an external stage that references the bucket and using the external stage instead. I think it's the same thing for Microsoft Azure too. I think let's go to next question. Yeah, what are the steps involved in loading data from a Microsoft Azure container? So the same process what we discussed for Amazon S3 and Google Cloud, and Azure container is Azure Blob or ADLS, where you can create a container. They call container, and inside the container you can create a folder. And we follow the same steps, like we make sure that we stage the files in Azure storage, and use the copy statement, copy into table state command to bring the data into Snowflake. And while we perform all these bringing data from external cloud storage into Snowflake, we must have warehouse, and also you make sure you create a warehouse according to your data volume. Let's go to next question. How do you troubleshoot issues with bulk data load failures? So there are two steps to check these data load failures. Step one, viewing the copy history for the table. And step two is validating the data load. Let's talk about step one. Query the load activity history for a table. So for information, check the copy history, and the status column indicates whether a particular set of files was loaded or partially loaded or failed to load. So we have to see the status column, and this is like performing in step one to troubleshoot in step one, viewing the copy history for the table. And also in the viewing the copy history for the table, there is like the first error message column provides a reason when an attempt partially loaded or failed. So you can find all the details using these two columns. One is status column, and the other one is first error message column that gives the description. Let's talk about the step two, validating the data load. The validation underscore mode copy option instructs a copy statement to validate the data to be loaded and return results based on the validation option specified. No data is loaded when this copy option is specified. Okay, and again, you can execute a copy statement with the validation underscore mode copy option set to return underscore all underscore errors. In the statements, reference the dataset files that you had attempted to load. Okay. And let's go to the next question. What is Snowpipe? A Snowpipe is Snowflake's continuous data ingestion service. Snowpipe loads data within minutes after files are added to a stage and submitted for ingestion. With the Snowpipe serverless compute model, Snowflake manages load capacity, and it ensures optimal compute resources to meet demand. So let's keep it short. Snowpipe provides a pipeline for loading fresh data in micro batches as soon as it is available. And Snowpipe enables loading data from files as soon as they are available in a stage. So it means we can load data from files in micro batches, making it available to users within minutes rather than manually executing copy statement on a schedule to load larger batches. Let's go to the next question. How does Snowpipe work? So we just discussed about Snowpipe. What is Snowpipe? Now, how this Snowpipe work in Snowflake. A Snowpipe loads data from files as soon as they are available in a stage. The data is loaded according to the copy statement defined in a referenced pipe. A pipe is a named first-class Snowflake object that contains a copy statement used by Snowpipe. The copy statement identifies the source location of the data files, that is stage, and a target table. So all data types are supported in Snowflake, including semi-structured data types such as JSON, Avro. So we just discussed what are the file formats supported in Snowflake. And let's talk about different mechanisms for detecting that staged files are available. So the first one is automating Snowpipe using cloud messaging, and the second one is calling Snowpipe REST endpoint. Let's talk about automating Snowpipe using cloud messaging. Automated data loads leverage event notifications for cloud storage to inform Snowpipe of the arrival of new data files to load. The Snowpipe copies the files into a queue from which they are loaded into the target table in a continuous and serverless fashion based on parameters defined in a specified pipe object. Let's talk about the calling Snowpipe REST endpoints. Our client application calls a public REST endpoint with the name of a pipe object and a list of data file names. So if new data files matching the list are discovered in the stage referenced by the pipe object, and they are queued for loading. So Snowflake provided compute resources load data from queue into a Snowflake table based on parameters defined in the pipe. Let's go to next question. How do you delete staged files after Snowpipe loads the data? So the pipe objects do not support the purge copy option. So Snowpipe cannot delete any staged files automatically when the data is successfully loaded into Snowflake database table. So to delete or to remove these staged files that we don't want them anymore, and what Snowflake recommends periodically executing the remove command to delete the files. If you don't want any files, and there is no option, but we have to check and periodically execute the remove command. And also, alternatively, we can configure a lifecycle management features provided by our cloud storage service provider. Let's go to next question, the 23. What is the process for unloading data from Snowflake into files? The files means the external, either Amazon S3 or Microsoft Azure or Google Cloud Storage. The step one, same, use the copy into the location wherever you want to send the data or unload data from Snowflake and send the data, and use this copy into location command to copy the data from the Snowflake database table into the files uh, are in a Snowflake or external stage. And the second step is download the file from the stage. So how do you download that file from stage in Snowflake? From a Snowflake stage, we can use a get command to download those data files. And how do you do that from S3 or Azure or Google Cloud? Um, we can use the interfaces or tools provided by Amazon S3 to get the data files from the Snowflake. It's the same thing in Azure and Google Cloud Storage. And if you want to know how to do that, how do we get the files from Snowflake, how to unload it, and please go to my channel. There, I have multiple modules that explains how we can download, and where I performed the exercise that I entered all the commands and successfully unloaded data from Snowflake into a different external cloud storage. They are Amazon S3 and Microsoft Azure and Google Cloud Storage. Let's go to next question. What are virtual warehouses? A virtual warehouse is often referred to simply as a warehouse. It is a cluster of compute resources in Snowflake. So the virtual warehouse is available in two types. One is standard and the second one is Snowpark optimized. And also, the warehouse provides the required resources such as CPU, memory, and temporary storage to perform the operations in Snowflake sessions. So, what are the operations? So, we can execute a SQL select statements that require this warehouse in Snowflake that require, if you want to run a select statement and you need a compute resources, example, you want to run select statement and retrieve rows from the tables and views from Snowflake database, then you must have the warehouse. And what are the other operations you can perform using this warehouse? You can perform DML operations such as updating rows in tables, loading data into a table, or unload data from a Snowflake database table. So without this warehouse, you cannot perform any of these DML operations. You cannot insert or you cannot update the rows in tables. You cannot delete it, and you cannot bring the data from external cloud storage into Snowflake, or you cannot move data from Snowflake into to external cloud storage. You must have a warehouse, and also you need to resize according to your data volume. You can select a small, medium, and also the cost varies based on your warehouse size that you created. Let's go to the next question, 25th question. What are micro partitions? All data in Snowflake table is automatically divided into micro-partitions, which are contiguous units of storage. Each micro-partition contains between 50 MB and 500 MB of uncompressed data. So groups of rows in tables are mapped into individual micro-partitions organized in a columnar fashion. So the size and the structure allows for extremely granular pruning of very large tables, which can be comprised of millions or even hundreds of millions of micro-partitions. So Snowflake stores metadata about all rows stored in a micro-partitions, that is including the range of values for each of the columns in the micro-partition, the number of distinct values, and the other one, additional properties used for both optimization and efficient query processing. And question 26, what is data clustering? Typically, data stored in tables is sorted or ordered along natural dimensions, that is, example, date or geographic regions. So the clustering is a key factor in queries because table data that is not sorted or is only partially sorted may impact the query performance, particularly on huge tables. And in Snowflake, as data is inserted or loaded into a table, a clustering metadata is collected and recorded for each micro partitions created during the process. We just discussed about micro partition, how that works in Snowflake. And Snowflake leverages this clustering information to avoid unnecessary scanning of micro partitions during querying, significantly accelerating the performance of queries that reference these columns. Let's go to the next 27. What is a clustering key? A clustering key is a subset of columns in a table that are explicitly designated to collocate the data in the table in the same micro partitions. And it is very useful for large tables where the ordering was not an ideal or extensive DML has caused the table's natural clustering to a degrade. Some general indicators that can help determine whether to define a clustering key for a table in a Snowflake. So that includes queries on the table are running slower than expected or have noticeably degraded over time. And the next one is the clustering depth for the table is large. So a clustering key can be defined at a table creation or afterward. So if you create a table and you want to define a clustering key, then you can use the command alter table and create a clustering key. And also, if you want to define a clustering key, during the creation of table, you can use the create table command and also define the clustering key. The clustering key for a table can also be altered or dropped at any time. Go to next. What are temporary tables in a Snowflake? What are temporary tables? A Snowflake supports creating a temporary tables for storing non-permanent transitory data. Temporary tables in Snowflake only exist within the session which they were created and persist only for the remainder of the session. So if you disconnect from the session, then you may not be able to see the temporary tables. They all drop. So make sure if you're creating a temporary table, so the session must exist. If you disconnect from the session, then you won't be able to access the temporary table. So that is the main purpose. Temporary tables only exist for session, and they are not visible to other users or sessions. If you're creating a temporary table in your session, so other users, they cannot access your temporary tables. And if you want them to access, so you have to create a physical table, follow other DDL standards to create it. But temporary tables only available to you in only for that session. Once the session ends, data stored in the table is purged completely from the system, and therefore it is not recoverable or either by the user who created the table or Snowflake. So if you are the owner and you create a table and you disconnect the session, and you won't be able to access temporary tables, and they are not recoverable, as Snowflake mentioned, it's purged completely. And let's go to the next question. What are the database objects can be shared in Snowflake? So secure data sharing enables sharing selected objects in a database in our Snowflake account with other Snowflake accounts. So the whatever mentioned in the answer, the database objects can be shared in a Snowflake. So they are tables. You can share external tables, secure views, secure materialized views, and secure UDFs. Go to next question. How does secure data sharing work in Snowflake? With secure data sharing, no actual data is copied or transferred between accounts in your Snowflake account. All sharing is accomplished through Snowflake's unique services layer and metadata store. It is an important concept because it means that shared data does not take up any storage in a consumer account, and therefore it does not contribute to the consumer's monthly data store charges. The only charges to consumers are for the compute used to query the shared data. What is a share? Shares are named Snowflake objects that encapsulate all of the information required to share a database. Data providers add Snowflake objects, that is databases, schemas, tables, and secure views to share using either these options, option one and option two. What is option one? Grant privileges on objects to a share via a database role, or option two, grant privileges on objects directly to a share. And we can choose which accounts can consume data from the share by adding the accounts to the share. Once a database is created from a share, all the shared objects are accessible to users in the consumer account. Let's go to next. What are the data providers and the consumers? A data provider is any Snowflake account that creates shares and makes them available to other Snowflake accounts to consume. As a data provider, we share a database with one or more Snowflake account. For each database we share, Snowflake supports using grants to provide granular access to control to selected objects in the database. That is, we grant access privileges for one or more specific objects in the database. And Snowflake does not place any hard limits on the number of shares that we can create or number of accounts we can add to a share. So Snowflake does not place any limits on that. And then what is data consumer? A data consumer is any account that chooses to create a database from a share made available by a data provider. As a data consumer, once we add a shared database to our account, we can access and query the objects in the database just as we would with any other database in our Snowflake account. And also here also in a data consumer, Snowflake does not place any hard limits like data providers. So we can share, and however, we can only create one database per share. What is column level security? Column level security in Snowflake allows the application of masking a policy to a column within a table or a view. Currently, column level security includes two features in Snowflake. One is dynamic data masking, other one is external tokenization. So what is dynamic data masking? A dynamic data masking is a column level security feature that uses masking policies to selectively mask a plain text data in table and view columns at query time. And what is external tokenization? External tokenization enables accounts to tokenize data before loading it into Snowflake and de-tokenize the data at query runtime. Tokenization is the process of removing sensitive data by replacing it with an undecipherable token. External tokenization makes use of masking policies with external functions. What is row level security in Snowflake? Snowflake supports row level security through the use of row access policies to determine which rows to return in the query result. The row access policy can be relatively simple to allow one particular role to view rows or be more complex to include a mapping table in the policy definition to determine access to rows in the query result. A row access policy is a schema-level object that determines whether a given row in a table or view can be viewed from the below statements, like from the select statements or a row selected by update or delete and merge statements. What is a tag? A tag is a schema level object that can be assigned to another Snowflake object. So a tag can be assigned an arbitrary string value upon assigning the tag to a Snowflake object. Snowflake stores the tag and its string value as a key value pair. The tag must be unique for our schema and the tag value is always a string. What is classification? The classification process samples all the supported columns in a table or view and uses the column names and values to classify the data into system categories provided by Snowflake. The categories can be assigned to the column as tags, which can be set manually or using the provided stored procedure. What are the classification categories? The Snowflake utilizes two category types of classifying data in a table or view column. One is semantic categories, other one is privacy categories. Let's talk about semantic categories. A semantic category identifies a column as storing personal attributes. Some of the semantic categories supported in Snowflake they include name, address, zip code, phone number, but right now it supports only US numbers and also age, gender. But again, if you want to check the complete list, please go to the Snowflake documents to get all the list of semantic category types. Let's talk about privacy categories. If a column is determined to have a semantic category, the column is further classified according to one of the privacy categories. They are identifier, also known as direct identifier. The other one is quasi-identifier, also known as indirect identifiers and and the last one is sensitive identifier. What is semantic? What is the semi-structured and hierarchical data? A semi-structured data is data that does not conform to the standards of traditional structured data, but contains tags or other types of markup that identify individual distinct entities within the data. And what is our hierarchical data? A semi-structured data is usually organized hierarchically. Complex data structures can be built by nesting simpler data types such as arrays and objects. What is Snowsight? A Snowsight is a Snowflake web interface. It distills Snowflake's powerful SQL support into a unified, easy-to-use experience. So we can use Snowsight to perform a critical Snowflake operations, including build and running queries in Snowflake and loading data into Snowflake database tables and monitor how our queries are performing and also copying S3 in a Snowflake. We can create the users and manage the users, and also we can manage the other account level objects. We can create virtual warehouses, and we can also resize it whenever we want according to our data volume. And we can also create and modify databases in all database objects in a Snowflake, and we can share the data to other Snowflake accounts, and also we can explore and using the Snowflake marketplace. Let's go the next question. What is classic web interface? We can use the classic web interface to perform tasks that would normally perform using SQL and command line. So those tasks including creating and managing users and other account level objects. And again, if you want to perform all these operations in classic web interface, you must have administrator role. Without that, you are not able to perform any of these tasks in classic web interface. If you have that administrator role access, you can also create and use that virtual warehouses, and also you can create and modify databases, and also within the database objects you can manage, you can modify schemas, tables, views, and you can load data into Snowflake database tables, and you can submit and monitor the queries, how your queries are performing, and you can look at the performance of the queries. And also you can change your password and set user preferences. Go to the last question. That is important question. And please remember this question. What are the supported cloud platforms in Snowflake? Snowflake is provided as software as a service that runs completely on cloud infrastructure. So it means all three layers of Snowflake's architecture, as we discussed, storage, compute, and cloud services key layers are deployed and managed entirely on these three cloud platforms. They are Amazon Web Services, that is AWS, and Google Cloud Platform, GCP, and Microsoft Azure. So all these supported cloud platforms, and you can only host your Snowflake account in these cloud platforms. And if you have any questions on Snowflake, if you have a question on creating Snowflake account or creating database, creating a table, creating warehouse or resize warehouse, or bringing data into a Snowflake or unload data from Snowflake, and there are a lot of external cloud storages, Amazon S3 bucket, Google Cloud Storage, or Microsoft Azure Container. And if you have any questions like bringing data from external cloud storage into Snowflake, and if you have question about Snowpipe or anything, and please don't hesitate. Please post all your questions in the comments, and I will try to reply as soon as possible. If you like this video, please subscribe and share the channel. Thank you.